Okay, welcome everyone. If you could please make sure you have signed in. There's different sign-in sheets floating around. So for our 145 presentation, we have Joseph Macak. He is the Vice President and Principal Consultant at Mostardi Platt. Joe has over 40 years of experience in environmental engineering, including 12 years with Commonwealth Edison in Chicago, 5 years with Westinghouse Power Generation, and 25 years in environmental consulting at Mostardi Platt, his current company. Joe directs the consulting and compliance monitoring group with a specialty in predictive and alternative emissions monitoring systems for permit compliance. Joe has a bachelor's and a master's in environmental engineering from the Illinois Institute of Technology in Chicago and has authored 38 technical papers. He is a member of ASME and the Air and Waste Management Association. Joe?
Thank you. So I'll just warn you, this presentation is basically, it's a 4-hour presentation compressed into 30 minutes. So I'll do what I can to speed through it. We're around. We have a booth here if anyone wants to talk about more of it, but I have some actual case data to show you. So the purpose of my presentation is to talk about certification documents you have for like regulatory compliance and whether or not your data meets the data quality needs. Give you some examples, a lot of things we find when we look into the data, and offers a number of suggestions for where you could have some improvement. So I'd like to start with 2 examples of things, we find when we do some inspections or assist with someone buying a facility, some of the things we find. First example is a new operator in an existing power plant, and permitting the facility was done in 1999. Is a major source. So they had 120-foot stacks with 25-foot diameter. Then what they actually built was 82 feet with a different diameter. Then when they did stack testing, the stack testing was done with another set of dimensions. There were no drawings, and then their Title V application had 70-foot stacks. The state was providing invalid monitoring data for other facilities to use for 17 years. And then the emissions test, this was supposed to be a 120-foot stack. And what they actually did is they put acoustic baffles in the exhaust right up to the test ports, and it invalidated where they're testing, but no one said anything about it. But so sometimes you find a lot of these discrepancies, and the EPA, when a US EPA inspection happens and they do multimedia and really dive in, you often find that they have, they'll look at all their old permitting and then start comparing it to what's in the Title V now and see what's been modified. The other example is with combined cycle power plant that's doing emissions reporting. So they have a NOx and O2 SEMS that's required because they're gas fired. And the CO particulates and VOC emissions are calculated based on emission factors from stack testing, and sulfur dioxide was based on fuel flow and the sulfur content, and they calculate, and that's the way everyone does it. But what happens is, like in this example, the NOx SEMS was set on a 0 to 100 scale, and it wasn't a dual range. And so every time they were starting up, they exceeded, but they were never measuring the emissions above that. And then they'll take the CO and VOC emissions from stack testing from when the facility started up. They have measurements that show that the emissions are, higher during a startup, and as they ramp up, then when you get to full load and they do the maximum load testing, it's basically 0. So they use that emission factor in all the annual reporting when it was only based on an optimal full load condition, and never report. And some facilities actually report 0 emissions burning, gas. Also, the fuel heating value of the fuel, sometimes they'll use they're still using a calculation for the amount of heat input based on, they'll monitor standard cubic feet per hour of gas and use an old fuel heating value from 10 years ago. And now with all the fracking, the heating value is a little bit higher, and it's basically like 3% higher, but they're still using old data from 12 years ago when it was quite a bit worse. And then when you ask the facility about it, they're saying, well, it's how, it's what we did last year. So that's about it. So if you're involved in any of the signing, a lot of times the people that are designated representatives to sign don't realize what they're attesting to, and they'll get a packet to sign. Then we have to send in our compliance certification, and they'll get it from a plant engineer, and they just sign it and send it out. They're actually obligated to really dive in and make sure your data is correct. And if I was a plant manager, I certainly would want to know if I could trust all the data and what they're telling me to sign. A lot of times, these plants are sold, every few years. And so a lot of the permitting history in between is going on. And it's really important to know as things keep changing, sometimes they'll put in equipment that was never there, and you have to stay on top of the permits and know it inside and out. This longer section here, but bottom line at the bottom is you can't have any disconnects between your construction permit and Title V operating permit. And it seems like almost all the time we'll see Title V permits that are issued, and they'll have emission limits and sizes of equipment. And quite often it's larger than what was originally permitted, and no one realizes that they just said it's in our Title V, but most of the intense EPA inspections, when they go back to the beginning and see if you have the right equipment there, and it seems like at least half the time they don't. They're missing something. There are cases out there where you have a duty to comply with these major sources, and if you don't do your monitoring or testing, you could have a permit revoked and rescinded. And we actually had over 1,000 megawatt facility in Arizona that they ran out of patients from the local agency, or the agency ran out of patients, and then they never renewed their permit in time. And so luckily we got in to help them, but the fact is they actually lost their permit to operate this facility that was needed for the whole summer. They ended up doing is just settling for a very significant fine, had to buy monitoring equipment for the local county, and they had to operate under a consent decree until the permit finally was issued. And EPA can do the same thing as if you don't maintain your equipment. They could also, so it could either be your monitoring or control equipment. They could authorize it. They could shut down a facility. What I wanted to point out in this example about compliance certifications is there's a group like, say, we're from EPA Region 5, our headquarters, and so US EPA has a group that will review these compliance certifications from other states. And then once they find out that there's a problem at a certain type of facility, it could be, some steel plant or a cement plant. Once they find out somebody starts having some issues, then they start passing the word around to other inspectors to look at the same issues at other plants. A lot of times they find problems that were never reported. And these certification statements, I think everyone knows that, you're certified under penalty of loss. So we make sure that if you're providing data, you want to make sure what you're given is accurate. And if you're the person signing it, you certainly want to make sure those that are giving you the data for the reports, and they have some type of attestation that, it's correct. Some of the new permits now, they actually have the actual names of who is authorized to be a responsible official. And we've seen communications where people would send in a report that wasn't listed in the permit, and it was not accepted until they got the correct person, the name changed, so they could be an official submitter of the report. Then if you're a duly authorized rep, you could delegate some of the responsibility, but you still have to have some responsibility for the overall operation of the plant. So there's some of these compliance reports are being signed by like the environmental manager or EHS person at the site, and they send it in instead of getting the actual executive to sign it, and they don't qualify. So then it gets caught later in an audit that, someone else is sending in a report that's not authorized to do so. What we always recommend is that if you're dealing with different facilities in a plant, like say a refinery, that you take, not everybody's, they may have subsets of the facility, and if there's data coming from different places, we always would recommend that there's like a program where each division or that's their subset of the facility, they do their own like certification to demonstrate compliance with the data requirements, and then from there they could compile all that and then go to the plant manager for signature. And we've been involved in a number of these where, we find that there's real problems with the data. And so I'll start going into that a little bit more further here. So like almost every permit's got requirements for fuel flow monitoring. And so if you have an emissions monitoring system, like you see a lot of the vendors out here, if you have that, you need fuel flow and the emissions data to do your emissions reporting. Sometimes you have data that the agency will say we need hourly files of their fuel flow, and they compare that to what the SEMS reports. Well, what we find things like a facility will be totally offline. You could tell from the 21% oxygen. Yet there's 8 million BTU per hour fuel flow being reported in the system. But then the EPA sums it up in an Excel sheet, and then the SEMS has a different number. Then they question why there's a big difference between the two, and it's because it's out of calibration. If you have a SEMS, there's a way to tell it whatever the fuel's reading, it doesn't matter, the unit's offline. But it could also work against you. So the fuel flow meters also have to be calibrated each year, and a lot of people just say, oh, it was checked, but there's no documentation at all. And then when they actually do a performance test, they could show that it's been off quite a bit. See when you're dealing with a lot of the permits, you've probably seen the ones that are like 300 or 400 pages long, and then you're supposed to remember every aspect of your permit compliance. So we always recommend that every section of your permit, you want to make sure you could document exactly how you're keeping track with the records. And basically you need to know it inside and out, and make sure you can determine how they're calculating certain things. So regarding the data quality, we want to make sure that if we're working on permitting for a facility, that you take into consideration the data uncertainty and what you're measuring, the decimal places in the application. and how you're dealing with all the different emission aspects. So, for instance, the decimal places in the permits, the EPA may put in a limit such as, 25 ppm of 3% oxygen. But then they put in the 4 decimal places for the pound per million. And when they do that, if you just looked at the ppm number, it's 25.49. They round down because there's no decimal place. But if you calculate it exactly for the 0.03 number, then it's 0.75 less. So when we look at, when we do any type of inspection and we look, it seems like more than 50% of the time, there's significant deficiencies in a lot of the paper or manual compliance records. And if it deals with SEMS and that type of record, it seems like 10 to 20% are deficient, which could be a lot better. A lot of times, though, sometimes you're lucky and you get an EPA inspection and the auditor just checks to see if you submitted a report, but they never look at the data. They just look at that was submitted on time. There's others that then dive into the data to make sure it's correct. So some of the manual compliance records, though, there are permits out there that say that for every startup and shutdown, you're going to do a manual adjustment to your emissions records for it. And they tell you to record the beginning and end time of every startup and shutdown and the date, you have to have. And then when you go and look at the records, they just guessed at how many startups and shutdowns. There's really no records of beginning and end times that's required in the permit. They also say for your annual emissions, you may have an exemption in your startup and shutdown emissions. With the permit for the annual compliance, you have to have some tabulation of it, and that doesn't get calculated. Then SCR and combustor maintenance, they'll have a program for their facility, but then the data does not, that they commit to doing for their maintenance, there's no record that it's completed. And they basically put in their operation and maintenance plan how they're going to operate the equipment, but then you need to prove that you're doing it correctly. So startup and shutdown emissions are, that's been in the last 5 years, it's getting more and more important to have some well-documented startup and shutdown emissions, because a lot of the states used to give you a blanket exemption of the quantity, and now those totals are showing up in permits as limits. So one of the things we always check is how a facility's doing those emission rates, and the inspectors are going to specific dates and asking for 1-minute data files and looking at that and seeing if how you're reporting it later. So here's a recent example of something we had where the permit has a mass emission limit for startup events. And then you calculate from the SEMS, you get pounds per million BTU off of the NOx and oxygen numbers. Then it computes the heat input from the fuel flow, and it calculates a mass emission rate, and then it divides by 60 so that you'll have every minute during the startup, it calculates it, and then it's supposed to sum it all up for that whole event. What's actually happening is that the SEMS, it starts up, and if this facility's been in an outage, and if it takes like 4 hours to do a cold start, the facility starts up, and during that time, the SEMS starts going through its daily calibrations. Then when it comes back on, those minutes are never added back in. They actually didn't monitor anything for each of them minutes. So for the total event, they're missing out on a lot of minutes of data that should have been summed up in the total. And that's something that's showing up in audits where people look at those events and then they try and calculate it and see how it compares to what the SEMS reports. Another is during a startup, the system was reading fuel flow. I guess you could see it, that it shows in the red column is a duct burner that's on. It's shown that there's fuel flow in the system during a startup. So there's heat input being added to the emission calculation. So while it's doing that, while it's through the startup, it's thinking that the duct burners are on. So it's multiplying the emission rates each minute by a higher heat input when in fact the duct burner was not operating, but it's got these false readings that it's operating. Then you'll find cases where somebody will have their startup and daily report for each hour. And it'll indicate whether you're in startup or normal operation shutdown. Unfortunately, this one says trip when it's offline, but it shows like that there's for startup and shutdown, the facility had a CO limit of 128 pounds per hour. And what the SEM shows is it was in compliance, but what happened in reality was during the startup, the SEMS was maxed out at 1,000 ppm. So because of that, they really didn't have any monitoring data in there. It calculated the emission rate, although it wasn't. It was just thought it was at 1,000 and not any higher. And another facility operates. They had a SEM system in for years. They changed the environmental person, every few years, and no one knew the whole history. But what happened, in early years in the 2011 and 12, they did their annual emissions reporting at the site, and then in 2014 mid-year they bought a new SEM software upgrade, and all of a sudden they're calculating carbon monoxide emissions that are quite a big bump. And then the following year, when they had the whole year, it looked like a major increase in emissions. And what it was is that the original SEMS vendor, while they had an emission rate, they just never included the startup and shutdown emissions in the permit, in the total for the year, because they said, well, it was, there was no limit, but you still have an annual limit that does include it. So that was that ended up in a notice of violation. They had to go back in time and get it corrected. Then you'll see a lot of boiler tuning cases where they'll come in with a little suitcase type of analyzer and take measurements. And we always recommend that you do like a linearity check of the instrument with real gas before you use it. Because what happens, some of them, they just assume everything is correct. So today we're at a plant where, it's got a certain readings, and it's basically, this is how it would look normally, that it appears to be working properly. But when you look at the range, it could be plus or minus like 5% of what's measured. And if you're trying to measure like 30 part per million type number, and it's 0 to 5,000 setting, and it's like plus or, the accuracy is not, you're in the wrong range for that level of, measurement. And these analyzers aren't as good as some of the, higher quality ones, but you just got to know what the limitation is. We've also seen where people would come in, they'll do all their boiler tuning before any kind of testing. Then you get there and you do the NOx, the tuning showed NOx and COs in compliance. But then when you actually test it, they've got almost 60,000 parts per million carbon monoxide going out. And it turned out that NOx was passing because it was just a lousy flame, but it was still heating in the boiler. But the burners fell apart and the tip fell off, so they're just spewing out gas without any type of diffusion. And carbon monoxide was like 6% of the exhaust gas, and they didn't know about it. But the monitor the little analyzer they had, the fuel cell that was measuring CO, looked like it was working, but it was dead. So they're reading 0, but the SEMS is showing, when we go do testing, it's 60,000. So that, canceled the test till they got the burner fixed, and then they had to redo it. We run across predictive emissions monitoring, and we love them. We do them all the time, but sometimes some of the data that you come across can be horrible of the way it's being used. So really, with predictive emissions, you're monitoring all these operating parameters, and you could predict an emission rate. And it usually you get like 100% data recovery and never have any issues. Except not all the PEM system are set up the same. So we've run into sites that bought software just because it looked real fancy in the presentation. It doesn't mean they're doing things correctly. But a lot of them are like a black box, and you actually don't know how the emissions are being calculated. So sometimes there's retuning going on that has to be recertified, but it's totally overlooked. And I'll show you a few examples. So one, we had a client at a university, they had a predictive emissions monitoring system. They thought there could be some issues with it. And we asked for certain data files, and then we find there's like strange incidences that kind of match up, that the whole curve is being adjusted in a range without any type of recertification. So it's not the same PEMS model. In addition, this is a recent one at another university. They're doing their predictive emissions, and the vendor comes in and says, whenever you're doing testing, make sure we know they'll be there to support it. So they go there, and then they start their first test run at 8:15. But at 8:09, all of a sudden the numbers jump, and they adjusted the calculation to more closely match the emissions data. So that was like a tuning event. But it's the same serial number on the PEMS model that was certified. But what you don't know is how it was changed. And clearly the data would never jump like this in any 1 minute. That's just impossible for it to do without a manual intervention. The same type of system, we looked at their hourly data, and it turned out that nothing in their PEMS was actually, they set it for a range that was from 29 million or 28 million BTU per hour or higher. So they had lots of hourly data, and this is just looking at the lower load data. And then it showed anything below 25 or 29 was set to 0. And there were a lot of hours like that they just had no emissions information being calculated, and therefore, what the predictions it was making were wrong, because they weren't doing mass emissions for every hour, including startup and shutdown. We do find a lot of underreporting of some of the baseline actual emissions that people do, and that's where they'll take emissions test data and they come up with emission factors, but they'll have their facilities that actually they'd have 4 identical units, and they test 2 of them. The first 2 had VOC and CO emissions that were measurable. The other 2 had basically, when they tested, they just had a less than sign, less than 1, and then they reported it as 0. So for 10 to 15 years, they're doing annual emissions reports based on this original stack test data that was rounded to 0. But all the units are identical, and they have 2 of the units just every year for their annual emissions reporting. They're reporting 0 tons per year for those pollutants, and it's clearly wrong. And that's another example, somebody saying, well, that's how we did it last year. But it's like, you have to know where the data is coming from, and is it right or not? Then there's the issue with, I'm okay on time, right? Yeah, okay. There's an issue with permit limits not being high enough. And so a lot of facilities get heat input restrictions, so many million BTU per hour or total amount of fuel per year. And then they may take, and they'll take emission limits that basically, hurt their operational flexibility. And even worse, some people will take the vendor information of new and clean equipment and use it exactly as they have it. And that's all based on a specific set of operating conditions and operating level. And then they put those numbers in a permit application with no margin for any type of measurement uncertainty or degradation of equipment. So one thing we did for one study was we looked for, some of the sources of error and some of the SEMS mass emission calculations. And so, what we looked at is, how accurate is each of the NOx and O2, how accurate is the fuel flow metering. You have test stratification in the stack, the equipment could degrade, and control equipment performance or the SEMS equipment, gas conditioner might not be doing as much as it should. All these different things, there's variation in the data, and you need to be able to account for that, some of the instrument drift or degradation, all that in your permitting effort. So what we did just for a SEMS, for example, we looked at for 500,000 cases, a permit that had a 9 ppm NOx emission limit. And we looked at, there's a fuel factor calculation, fuel flow measurement, the heating value of the fuel, and accuracy of the instrumentation, all that. We looked at how, assuming a normal distribution of the way it's operating, we looked at how that might affect the emission rates. So for instance, if the NOx is drifting high and the oxygen's drifting, one to the other direction, you do the calculation, how much could the value vary and still be considered, within the limits of the accuracy. And what it showed is, if you wanted to look at a rate, if you wanted to be at a 95th percentile value of, dealing with, in this simulation, the measurement uncertainty, you needed like a 1.11 multiplier on the mass emission limit to account for the measurement uncertainty. So if they go back and test and everything's within spec, that 95% of the time you'd for sure be meeting those requirements. What we find with SEMS measurements and QA, if you have a SEMS, you probably have the requirement to have a QA/QC manual that deals with how you're going to take care of the equipment. So a lot of people will buy a SEMS and then they never actually, they just get some instruction manual, but it's not a QA/QC manual. So they end up never having one. And the EPA will come in and they'll see your permit says you have a QA/QC manual, and then they go look, when you look for it, no one knows where it is, or it hasn't been updated in more than 10 years. And in that time, the analyzers were replaced and recertified, but the manual's never updated. And these are, that's just a sign of, doing some poor, you're not staying on top of your monitoring system. So we always highly recommend, that you inspect all your systems. If you don't have an updated QA/QC plan, you should do it, but then make sure you follow what's written about inspecting the systems and don't start taking shortcuts. You don't want to rely on one person doing all the instrumentation, because when they leave or get sick, whatever, someone else has to take over. And then they'll say, well, I didn't know I had to do something. You always want to make sure you have more than one person available. But here's some of the examples we see that, somebody will not be doing the preventive maintenance, Then we get a call and go out there to fix their opacity monitor, and there's nothing wrong with it. It's just that so much rust and ash built up in the port where the opacity monitor was, that the light beam wasn't going across the stack and back, and it was reading 100% opacity. So that's just indicative of, you know, poor maintenance. You have metering out, and there's weatherproof covers, yet, you know, sometimes they don't put the covers back in, or it just turns into a big birdhouse, or mice move in. We find a lot of that stuff that if an EPA inspects it and they see that, it right away tells them you're not doing your paying attention to your QA/QC plan, because you wouldn't allow that to happen. At least once a year, you should be pulling the probes out of the stack to inspect it. And some people just, it's too much trouble to do it, so they just assume it's okay until it starts cracking apart. And then when you get do an audit, you may start having some real issues, especially when the end of the probe falls off. We go look at the SEMs and check their drawings, and then you get there and then you find they have a terminal block with a whole bunch of wires cut off, and it showed old drawings that had something there, but then all of a sudden, you know, things have been updated and they leave the wires hanging, and it looks like someone's, you know, going out of their way to mess around with your SEM system, and we've had a state inspector in Indiana looked at one of these and said he saw wires hanging, and it made, you know, he's taking pictures of it for his report. And it just shows that you're not paying attention to the system when you're not updating these things. Then others will put in SEMS equipment and monitoring, and they don't put the, you know, heated sample line in correctly. Then there's no safe way to access it for preventive maintenance. So then they just never go, because there's no platform or anything. They just mounted a SEMS in there, and they basically, once it was in, they forgot about it. And sometimes they'll buy an expensive computer system or server to store, you know, do their SEMS data processing, and then they put it in some cabinet that's not air conditioned. And then the temperature you measure is well above 120 degrees, and the SEMS fails, and then they lose their data. And then they have to, you know, beg for forgiveness when they're missing that. In contrast, you know, if you want to use the cabinet, you could always do a small cabinet and put the air conditioning unit on the side, and everything stays the right temperature, and you don't have any issues. So, just in summary, you know, talking about a lot, you know, with the data, we just want to make sure that, you know, if you're doing any type of, if you have any type of problems at the facility, if something's broke or some data's missing, you need to address it immediately. If you're missing data or old reports because you're like a new owner taking over a facility, you do the Freedom of Information request to get it old data records so you have it. You want to make sure you have a backup for doing all the different EPA reporting and SEMS maintenance, just because you can't always rely on one person to be the guy. When you're doing the permitting and you're looking at, you know, emissions data provided for a piece of equipment that you're going to put in a permit, you know, you don't want to rely on it being using just the new and clean, brand new performance numbers. You want to be able to make sure you have some margin of operational flexibility in there. One thing I took a section out that dealt with some of these QA/QC inspections, but it's still in here. There are requirements where it'll say calibrate your fuel flow meter every year, and what you're supposed to do is document as found and as left if you're making an adjustment. And we find it seems more often than not when we see the reports that are, you know, they say they check their flow meter, they just say basically they leave the as found, and they may make an adjustment and pretty much say it was calibrated and that's it. But then you don't know how it may have changed, how much it had to be adjusted. And they ask for the before and after data in those QA reports if you follow the procedures exactly. If if you have emissions data you're using in your reports or any of the compliance data, you want to make sure you could be prepared to prove it's accurate. And be familiar with things like where I showed the emissions data going over range during startup and shutdown. If you have that problem, it's easy to fix, but you just have to deal with it. To have reported that, and find that, after the fact, you've got years of the system maxing out on the emissions. Technically, you're supposed to go back, at least 5 years and correct that, or make some type of adjustment to your reading so that you get the more accurate tons per year emissions rates. And then finally, make sure your permits is accurate. You can demonstrate compliance with all permit conditions. So a real smart thing to do is you look at every single condition in your permit and be able to demonstrate, whether it's continuous, intermittent, or you need to demonstrate you're in compliance with every single section, and then you should then document where the data is coming from. If you need to put who's responsible for it, you put that in your big table that analyzes it. But it helps then if somebody else has to come in and then the EPA says, I need your records, that's this section of the permit. The instruction will then tell you, here's how you get it or where you find it. And I had a lot of more interesting case stuff that I had to take out of here, but there's some real crazy data things and questionable data out there. And it seems like if you really dive in, you may find things you want to fix and find it before the EPA finds it for you. So if you need further information, I'm around this week. We have a booth here. And any questions now?